Alright guys, welcome back. We're still on the primitive topic, primitive variables. The next two variables we're going to be talking about is float and double. Alright, let's go ahead and take a look at this program we have. And we have made a double type variable. Alright, well, what's a double type? A double type holds decimal values, okay? And a double type holds 64 bits. Okay, that's one of the bigger variables. That's the biggest one. So far, our long holds 64 bits, and then the double also holds 64 bits. Those are the two biggest primitive type variables. And it stores decimals. So let's take a look at 3.14159265535. And we run it. And it displays that number. Okay. Well, that's pretty much it. It holds negative as well. Let's talk about the range. And then we're not, because the range is not within the topic. That's what it says right here as well. There's obviously some links right here that talks more about the range, but in this series we're not going to talk about that range. Okay? Just to cover it real quick, the bigger this whole number portion, the less accurate this becomes. But we'll talk about accuracy using a different data type that's also mentioned in this tutorial called the big decimal. Okay? It's not a primitive type, but that's something that can be discussed later. Alright, next is the float type. Okay, well, what's the float type? Well, it's a smaller decimal. It's not as accurate, but the advantage is it takes less memory. It takes half the memory. Okay, so it's kind of like the int type, and related to long. It takes half the memory, but doesn't store as many values. Something like that. Alright, well, let's take a look at this error that we have. Possible lossy conversion from double to float. Let's go ahead and see if this actually runs. I'm going to run it anyway. It crashes. Okay, well, this brings us to another topic. It brings us to literals. Right? We already talked about character literals and string literals. Well, guess what? There's also integer literals, which we didn't discuss last, which I didn't want to. And we got floating point literals. If we want to make this a float, we're going to slap on an F at the end of this, okay? That's all it is. Even a capital F will work as well. Let's run this. 3.1415927. Notice that it gets chopped off at a certain point. Notice certain values get chopped off. Well, that's the disadvantage of a float. Is that if you need to be accurate, you don't want to use float. So, but if you don't need to be entirely accurate, if you only need to have 1 or 2 decimal points, you might just want to use the float. Okay. But the point is that you'd have to use a float to make this a floating literal. So this is already a float type before it gets carried over to the float variable. Okay. Now, guess what? Can you have a double in a float? Absolutely. But guess what? This gets converted first. Let's run this now. 3.1415927. Notice that it doesn't match this number over here, because this was converted into a float before it gets assigned. So right here, this is the assignment operator. We're going to discuss that a little bit more in depth later. But this portion gets converted to a float type, which means it's not as accurate, then gets pushed into a double. And we got some random noise of, because this is not the number I typed in. However, if I get rid of this F, poof. Oops, I clicked. Let me run it. Then it matches what I typed in. So we can see a little bit of accuracy discrepancies when we're talking about float and double. Okay? General, I like to use double personally, but depending on your application and depending on how many variables you make. Yeah, I remember again, I said it before, the size of the variable matters. Or the size of, or I'm sorry, not the, alright, forget that. The number of variables matters. So when we start making arrays, we start making hundreds of thousands of variables that may or may not get generated based on user action. It'll matter, but right now it doesn't. But know that memory is being taken up on your RAM when you run this. Okay, that's it for float and double. We talked a little bit about decimal literals, which was kind of extra, but it's necessary if we need to establish a float. And we still have 3 primitive type variables that we haven't talked about yet. And we're going to discuss those in the next couple videos. Thank you for watching, and I hope you're getting something out of these.